Okay, a flagpole GH shown on the diagram. So G to H is vertical and the ground is inclined at an angle of 5%, at 5 degrees to the horizontal between E and G. The angles of elevation from E and F to the top of the pole are 35 and 52 degrees respectively. How far is F from the base of the pole G along the incline? Give your answer correct to 2 decimal places. So it's really looking for F to G here. Okay, F to G. Now, the most important line in a diagram like this, see the way F to G is clearly located on the triangle on the right hand side. So this is F to G right here. And currently speaking, I don't know anything about this red line here, G to H, and I know nothing about the green line, H to F. I could do it knowing one of them if I'm to find out what one of the other ones is. Okay, so that'd be a good start. Okay, so what we're thinking is what we're thinking is 6 over, I think I'll be able to get all the angles here because I can take 52 away from 180. So I can do 180 take away 52. And I can find out that that's 128. And then I can do 180 take away 128 and 35. 35 and 128. And I can find out that that is 17. Okay, and I could probably find my way to finding that green side pretty quickly, which might be a good solution. So we're going to try and find HF, which we'll call X. HF is the line that links both triangles together, so it might be a handy one to know. So here's what we'll do. How far is F to G? The blue is the goal of the question, but I'm going to go after the green part first. So I'm going to do X. I'm going to use the sine rule because it's not a right angle triangle, so it's going to be X. So we're using A over sine A equals B over sine B. And I'm going to use X over sine 35. And then I'm going to use 6 over sine 17. I'm going to cross multiply up the sine 35, which is division on the right. It becomes multiplication on the left. And what we're going to get 6 sine 35 divided by sine 17. And we're going to get 6.2, 6.27. Maybe I did this wrong. Give me a second. Have I done something wrong here? X over sine 35, 6 over sine 17, 6. Oh, I'm in. This is part of the reason why you're sometimes looking at the marking scheme. See the way I'm in radians mode? I should be in degrees. So most of you at home will be disagreeing with me at the moment. So 11.77. Now, the next problem resides in the green, red, blue triangle. Now, I know this is 11.77 now, but the problem is I don't really know any angles in here, or do I? So if that's 90 and that's 5, that means that this angle here has to be 85. I'll just put in the 85 for those who don't know. This angle here has to be 85. And this means that this angle here has to be 95 because it has to add up to 180. So having in there, if that's 85, that's 95. I can once again use the sine rule, and I'm going to find I'm looking for the blue line. So I'm going to get 180 I'm going to take away 52 and 95 to find out the, that's 33 right there. Okay, so now I have a sine rule. I'm going to call FGX once again. I'm going to say that it's x over sine 33 because the 33 looks at the x and the 95 looks at the 11.77. So you can see that this question is just basically the sine rule twice, even though it looks quite the heavy question. Okay, and we're going to do 11.77 sine 33. Hopefully I'll divide that by sine 95. And we should get an answer of 6.43, which is the correct answer. And I got 6.43. Yeah, 6.43 is grand. Some people might get 6.44 if there's different rounding going on and it's in meters. Okay, now let's see what else we're doing. On to part B. The diagram has a large circle that has a center at O and a small circle C at a center of D. The circle C touches the circle S. Small circle touches large circle at a common, basically a common tangent, if you will. That's a C is a common tangent. Okay, at point C. OA and OB are the radiuses, are tangents. So the radius of the larger circle is actually tangents of the smaller circle. You can sort of see that it comes up and it hits the smaller circle only once. Okay, so that's pretty cool. The angle BOA is 60 degrees, which in turn will mean that they're both chopped up into 30s because it's going to be symmetrical. The ratio of the angle of the area of S to the area of C is K is to 1. Find the value of K. In essence, we're trying to figure out how much bigger S is compared to K. How much bigger is the angle S, is the circle S compared to the circle K? All right. So let's figure out what we're doing here. I see a right angle triangle, and often that's a good way to begin. So does everybody see the right angle triangle I'm talking about? I'm talking about this right angle triangle here. I might be able to get an easy win here. Okay, maybe something like this. Now, I can't guarantee, I don't think that's a midpoint or nothing like that, but I'm trying to figure out, I can figure out what O to D is pretty quickly. And then I can figure out what O to C is. Ah, that's what it is. See, O to C is the same length as O to B, and O to B is the same length as O to A. They're all radiuses. So we know that D to C, see the green part here? D to C is R. And what I would love to know is I'd love to know this blue line here, because I could add the blue line to the green line to find the total radius in terms of R, which makes things really easy for me. So what I'm going to say is that it's sine 30, because we're going for opposite, which is R, and hypotenuse, which is O to D, we'll just call it X. And then X equals, X multiplies up to the sine 30, and then the sine 30 goes down. So it's going to be R over sine 30. Now I'm just going to do 1 divided by sine 30, see what happens. Sine 30 on the bottom, 2. So X is actually going to be equal to R, because it's actually going to be X equals R divided, sine 30 is a half. 1 divided by half is 2, so that's why it's 2R. Now I know that X is 2R. Okay. Now I know that the radius of the large triangle is 3R. So area of, which one are we talking about here? Area of S is it's pi r squared because it's a circle, but it's pi 3r squared, which is 9 pi r squared. And the area of C, which is the smaller triangle, is just pi r squared, which is still pi r squared. One of them's 9 times bigger than the other one, so it's a ratio of 9 is to 1. It looked like a crazy question, but in the end, it really wasn't. Okay, so that's question 3 done.